If you are new to the channel, then subscribe the channel and press the bell icon for further notification. Okay student, welcome you all to this new lecture in power system series. So today again we will be solving 5 questions starting from question number 211 to up to 215. Okay, then let's try to solve these questions. We come to question number 211. For harnessing low variable water heads, the suitable hydraulic turbine for high percentage of reaction and runner adjustable vanes. So for low variable water heads, you know it is always Kaplan. So there is no way you should think in other way around. It is always A, that is Kaplan. So if you come to now 212, out of these following plant categories, this one, the base load power plant. Now in this type of questions, you have to see what are the plants that given to you. And based on that, you think which one should be your base load and base load power plant and then peak load power plant. Nuclear runoff, this type of 4 plants only you have. You don't have any other plants. So you have to support that base load. So one thing you have to see that runoff lever actually basically this hydraulic plant where the water storage is very low. So there is no water storage, you can say. So there is no water storage means the water that is coming from the river, that is used for rotation of turbine and that part goes away. So there is no storage. So if there is a change in load, it cannot provide that additional load because there is no additional load storage. You cannot increase the input to turbine. So this always has to be your base load. So 2 always has to be in the option. So you can look around the options and all options, almost first 1, 2, 3, these are all involving 2. So it should be, so this one is not answered. Next, nuclear you cannot suddenly switch it on, suddenly switch it off. So peak load, it will be suddenly it will come and then after some time it will go. So rate of rise of your load cannot be maintained using nuclear because it is tough to stop a nuclear power plant immediately and to start immediately. It takes time to start also, it takes time to stop also. So this has to always maintain that nuclear base load. So again 1 should be always an option. So option A, 1 and A and C. Now here you can say 1, 2, then pump storage. Pump storage is specifically for this is for peak load, because in pump storage what we do, in normal load it works like a load, it looks like a motor, it stores water from the ground level to a height, and when peak load occurs then that water is released to supply in the peak load purpose. So this is particularly for peak load operation. This is not for normal operation because here water is stored during off-load time, off-peak load time, because it works sometime as load, sometime as generator. So it cannot work always as a generator. So obviously 3 will not be the answer. Now diesel. Now diesel is very costly, but you can see your nuclear and runoff, if you are using this one as a base load, if there is a little change in the loads, not peak load is coming, but there is always a load fluctuations. So that fluctuations cannot be maintained using these 2 because nuclear controlling that will take time and runoff is also. So for that little variation you need to have that diesel also, so that you can vary, the little variations in load can be maintained. So in this case the perfect combination will be 1, 2 and 4. So that is your option C. So that's why diesel is coming. Otherwise diesel is not a base load, but here you have no other options. For little fluctuations you have to use that diesel. If you are using this one as a full, then if there is a before peak load also coming, there may be a little variations in base load, that will be dealt with the diesel. So that's why 1, 2, 1, 2 is C. Now if you come to 2, 1, 3, again base load power plant, now you have this type of plants. Okay, so now you can say runoff should be always based. So Q should be in your options, that is B cannot be in your answer. Nuclear is also a base load that we have already discussed. So Q and R. So Q and R should be always there. That means this is not answer, this is not answer. So these and these, either these 2. Now if you come to wind farm, there is a continuous fluctuations in wind. So you cannot be guaranteed that your wind will be there in time for peak load. So it cannot be used for peak load. Because it is a generator, you have to use it. You have 4 generators, you cannot keep it alone. So because you cannot use it in peak load, so you have to use it in base load. So this wind is also be using in base load, because there will be always a fluctuations in wind. So that can be controlled using gear arrangement or this, so that its output can be controlled as a constant, and if required you can reduce it output, increase it output. So the earlier case, what was the problem with this, that little change you are not able to compensate, that's why you have to choose diesel. But here you need not to choose diesel. So you can use it, that little fluctuation can be dealt with wind farm. So the combinations will be PQR, and you keep this one as a peak load. So because you have four type of plant, so use these three as base and you keep this as reserve. So in terms of peak load, you use this one S. So obviously it will be PQR. So 213. So this type of questions depends on situations also, but some of the plants are there which will always for base load side, like as your runoff, nuclear, wind farm, pump storage is always for peak load. Now diesel, you are on based on situation, it can be used as base also, it can be used as peak also. The main problem in diesel is it is costly, that's it. So you use it properly where it is required. 214. HVDC transmission is preferred in extra high voltage AC because HVDC terminals are inexpensive. No, it is wrong. It's very expensive because you need one side rectifier, one side inverter. So these are very costly. So bar compensation is always required in HVDC because in HVDC transmission line you don't have L, we don't have C. So the Q cannot be transferred. So it is only a P that is transferred. So but load requires Q also. So you need to give this bar compensation, that reactive power compensation in this side, both sides you have to provide this compensation. So this is obviously it is wrong, it is required. So system stability can be improved. Harmonics problem, system stability obviously in HVDC system that is improved. So that is the benefit. And harmonics problem is avoided. It is not, because harmonics will be there because you are connecting one converter and inverter. Whenever you are using power electronics devices, so harmonics will be always there. So that's why it is not that it is not avoided. It is rather coming here in HVDC. So A, B, C, these are the problems of HVDC. These are not correct. So therefore 214 it is option C. Now if you come to 215, bulk power transmission over HVDC line is preferred on account of. So what is the benefit of HVDC line? It is actually stability can be improved, and another one, the main thing is that the loss can be minimized because there is no LC. So that losses can be minimized. So therefore minimum power loss. It is not low cost. It is not harmonic. We have already seen the protection is also complicated. You need that converter, inverter. So all this makes your system load quite complex. So that's why it is. The main advantage is minimum power loss. The losses are minimized here. If you like the video, then press the like button and please give your valuable comments in the comment section.